So question 14, let me get rid of this graph real quick here. It's the previous question. So question 14 says, solve again the exponential equation, express irrational solutions in exact form. So again, our strategy is like before. Notice how our bases are not the same. This is a 5 and this is 6. So we can't just set 1 minus 4x equal to x because the bases are not the same. So the strategy is to take the log of both sides or take the natural log of both sides as our strategy. Because remember, the property of equality says whatever you do one side, as long as you do the other side, the equation remains equivalent. So this is cool things you can do with equations. So I have 5 to the 1 minus 4x equals 6 to the x. But what I can do is take the natural log of each side. So this becomes the natural log of 5 to the 1 minus 4x equals the natural log of 6 to the x. Now we can actually apply the properties of logarithms. So this exponent 1 minus 4x can come down as a coefficient. So we have now this 1, I'm going to have to put in parentheses, 1 minus 4x parentheses times the natural log of 5. And then this x comes down as a coefficient. So this whole quantity is multiplied to the natural log of 5. So to solve for x, we first need to remove these parentheses. So I need to multiply this natural log of 5 back through here. So 1 times the natural log of 5 would just be the natural log of 5. And then natural log of 5 times this -4 becomes then minus 4x natural log of 5. And then that's going to equal then x natural log of 6. So one of the things we can pick up on is we need to combine our x's together, so that they need to be on the same side of the equation. So since this one's negative, I want to go ahead and move it over to our side and make it positive. So I have this natural log of 5, and this is going to equal then x natural log of 6, and bring that over, make it positive. That becomes then plus 4x natural log of 5. Now what's kind of cool is, since both of these have a common factor of x in them, I can actually factor that x out. So this natural log of 5 is going to equal then, the x could come out as a common factor, and then I put in parentheses what's remaining. So if I factor the x out, that's going to leave me the natural log of 6. If I factor this x out, that's still going to leave me the 4 and the natural log of 5. So remember, when you factor it out, you're essentially dividing it out. So if you divide the x by x, it's just going to divide out and become a 1, which leaves you the natural log of 6. And when you divide the 4x natural log of 5 by x, the x's divide out and leaves you this 4 natural log of 5. So when the x comes out, it disappears from the terms inside there, if you will. Now, to get x by itself, though, I need to go ahead and divide each side by this right here. So if I divide natural log of 6 here, 4 natural log of 5, I got to divide the other side by that as well. So the natural log of 6 plus 4 natural log of 5. So that means the x is now by itself. This piece here actually divides out. So the x is by itself. So x is going to equal then the natural log of 5 divided by the natural log of 6. Still kind of mess that up there. So natural log of 6 plus 4 natural log of 5. So that's going to be our exact answer. So that's what we'd be putting in our solution set. Now, if I want to figure out what that is as a decimal, so we do the natural log of 5. And if I divide it by this quantity here, so if I put that in parentheses, the natural log of 6, plus 4 natural log of 5. Close that parenthesis. If I enter, that gives me that. Or again, if you rather use the fraction button, alpha F1, you can also use that mode there. So natural log of 5 over the natural log of 6 plus 4 natural log of 5. So it's the same answer. So as a decimal, we would say, would that be 0.195 or 0.196? So if I'm rounding it 3 decimal places, and I can't remember if they do that or not in there, but I don't know if they even do that at all, but 0.196 would be the estimation. Now, if I want to verify my answer using the graphing calculator, remember, if you set this to 0, you can graph then the function y equals 5 to the 1 minus 4x minus 6 to the x. If I graph that and find the 0, so y equals 5 to the 1 minus 4x minus 6 to the x. If I graph that, looks like the 0 happens pretty close to 0. So second calculate 0. So if I do my left bound, that looks pretty good. Hit enter. Go to my right bound. That looks good. Hit enter. Hit enter again. And notice that we did get this 0.1955. So 0.196 would be the estimation. But again, they asked for the exact answer. So this would be the exact answer. Notice that this does represent an irrational number. So remember, logarithms that you cannot take the log of are just like square roots that you cannot take the square root of. They represent irrational values. And all we can do is change them to decimals.